Hi, everyone. So we're going to do a little lesson together on variables and expressions. So you want to have that note sheet in front of you. Okay, so a couple terms and definitions. Remember, you can pause this at any time you want. You can see a variable is a letter or symbol used to represent a value that you can change. A constant is a value that does not change. Numerical expression contains only constants and or operations. And then we have an algebraic expression, which has variables, constants, and or operations. Okay, we're going to want to be able to translate between algebraic expressions and words. Okay, so here's some of the symbols that we want to make sure we know. Again, you can pause this at any time. Okay, let's take a look. Give two ways to write each expression. So I'm going to put up some expressions here. You might want to give it a pause for just a second and see if you can figure out two ways to write each one of these. Okay, here we go. So the sum of x and 3 is one way you could say that first one. You could also say x increased by 3. Those would both work. For the second one, the difference of m and 7. Could also say 7 is less than m. 2 times y on that third one, the product of 2 and y. And then you could say k divided by 5 or the quotient of k and 5. Okay, so here we go. Just some other words to be thinking about, be thoughtful about. Sometimes we want to translate from the words into the algebraic expression. So for example, let me just move myself here for a second. Okay, so for example, Eve reads 25 pages per hour. Let's write an expression for the number of pages she reads in H hours. Okay, so H represents the number of hours that Eve reads. So a couple of ways that we could say this is we could say 25 times H or simply 25H. All right. Okay, so you might want to pause it and get this down, but to evaluate an expression, that means to find the expression's value. And a replacement set is a set of numbers that can be substituted for a variable. Okay, so let's look at an example. Evaluate each expression where we're going to use the replacement set 2, and then 4, and then 5.7. Okay, so here's our expression. So first, what we're going to want to do is take the first number we were given, 2, and substitute that in for the x. Okay, so here's our expression. If we sub in 2 for the x and then go ahead and work that out, 2 plus 8, that's 10. Perfect. Okay, next one, we have x plus 8. Now this time we're going to sub in, replace the x with a 4, substitute in a 4, and so we're going to get 12. Okay, and then the last one, 5.7, and 5.7 plus 8 is, of course, 13.7. Okay, on to the we problem. Okay, so let me just move myself here. Okay, so there's two ways. We want to give two ways to write each of these algebraic expressions. Okay, so you might want to pause it here, give it a try. But I think one way you could do it, on the first one is to do the difference between 4 and n. Okay, or you could say n is less than, or n less than 4 rather. Okay, and then t over 5 for the second one, we could say the quotient of t and 5. We could also say t divided by 5. All right, and so lastly, the UL problem. As you know, of course, I will not show you how to do these. I'm just going to put up the answer, so why don't you pause it and give it a try. And here you go. Here are your answers in order. So the answer to when we sub in a 2 is 1, a 4 is 2, and a 5.7 is 2.85. All right, thanks for watching. Good luck.